Hello, everyone, and welcome to today's 10-minute take with UST and technology advice. I'm Corey Knowles, and I'll be your moderator today. Our topic is seeing double, how telcos use digital twins to predict, plan, and prevent. So, networks never sleep, and neither can the way we plan and operate them. Digital twins create high fidelity virtual replicas of telecom infrastructure, giving operators the ability to predict issues before they happen, keep performance tuned in real time, and roll out upgrades with far less risk. To explore how this technology is reshaping telecom, I'm joined today by Paul Morrison, General Manager for Telecommunications, Media, and Technology at UST. Paul, thanks for being here. So, Paul, when people hear digital twin, they often think of manufacturing or smart cities. What does a digital twin mean in the context of telecom networks, and why is it such a game changer for planning and operations? Like, what's changed in the industry that makes this the right moment?
Yeah, well, everyone has a slightly different definition of what a digital twin is. And I think that's part of the problem. I've seen things like ERP systems described as a digital twin of a supply chain, or, a Salesforce implementation as being a digital twin of a customer base. And I think, those are like pretty good definitions, but they're very broad and probably too broad to be actually useful in particular environments. So, whenever we think about digital twins, we think it a much narrower representation. So we think of it as something that helps kind of reflect the telco's physical network in one form or another. So there are three major types of digital twins. There are static digital twins, there are dynamic digital twins, and ones that are predictive. So an example of a static one would be where you're building a digital twin of a tower network. So tower networks don't change that frequently. You don't have to have real-time updates from the towers themselves in many instances. From the antennas, sure, but it's not as if the locations change on a daily basis or you're getting different information every 5 or 10 minutes. So a static model of that is actually useful because it allows you to do things like track assets. It allows you to sell capacity on those towers and so on. So that's the base level that you can imagine. A dynamic digital twin is something where you want to see real-time changes of what's happening in the network. And that's the one that we're probably most familiar with. So you go into a network operations, you can actually see in real time what's happening to the network overall. The most interesting of the digital twins, though, are the predictive ones, the ones looking forward that are capable of simulation, where you're able to go in there and actually say, well, what happens if the networks changes in this way? What are the outcomes? What are the changes that we can actually anticipate going forward?
So, digital twins can transform static network maps into living, evolving models with predictive analytics layered on top.
Mhm.
How does that combination help operators in real time and prevent problems before they ever reach customers?
Yeah. Well, telcos have always had kind of real-time feedback on how their networks are behaving. The people who supply a lot of the hardware and software associated with the networks have their own tools. Those tools end up in network operations centers. So there's a lot of feedback in real time as to what's actually happening on the network. The issue is that sometimes that can be a bit overwhelming. So it's kind of like the control room at Chernobyl problem. It's like you have something go wrong, but then that something going wrong has the impact of setting off 20 alarms. So you have too many of these things happening simultaneously for you to kind of like work out what the root cause of any particular problem is. So this was a problem for a long time in telcos. There was a lot of effort put into trying to fix this in one form or another. And the good news now is that things like AI enables us to do like real-time root cause analysis. So 20 alarms might go off, but the AI system will be able to tell you relatively quickly what the real root cause is. So there's benefits associated with that. And it's not as if these models are going to remain kind of like fixed kind of going forward. It depends a lot on what the telco is looking for. Sometimes the telco is looking for more financial information associated with the network. Sometimes, one that's popped up a lot recently has been things like energy efficiency. So energy efficiency had been treated, to some degree in the past, but not to the level that it's anticipated going forward. So that becomes top of mind, and a lot of network operations is going to have to evolve to incorporate those kind of measures going forward as well.
Wow, that makes a lot of sense.
Hmm.
So, rolling out services like 5G expansion has big risks. How do
Hmm.
digital twins let operators safety test upgrades, and what difference does that make in the customer experience on the other end?
Yeah, well, and if you're kind of like rolling out new services for things like 5G, digital twin becomes like really important for things like, testing coverage in a particular, area. So it's really useful whenever you're doing project execution. So before you've committed to a particular configuration as to what your network is, a digital twin can actually say, well, okay, let's think about how that thing might operate in real life. So a good example is we have an AI tool called GeoMoon that creates a digital twin of network coverage. So you can actually look at what the anticipated coverage of your network is in a city block, and then in a building, and then potentially in the floor of a building, and draw some distinctions between coverage externally and internally, whether it's indoors or outdoors. So you can play around with it and you can optimize kind of coverage before deploying in the real world. And that saves you time and money and effort and all of that stuff going forward. So whenever you're rolling out those services, that's something that's of interest.
Really interesting.
Mm.
Implementing new technologies often raises questions around cost and
Yes.
complexity. What's your
Mhm.
view on the investment case for digital twins?
It takes some time to actually work through the elements of this. I think most people find that, the investment required in the past was very, very high. And in some instances, it had skill sets that telcos themselves didn't really have in a huge amount of detail. It's become much more standardized recently. There are still point specific use cases that are actually quite complicated. So anything where you have to physically represent the real world is still a little complex whenever it involves you working like that. A good example again is things like tower networks, where if you want to do a three-dimensional model of, let's say, an antenna and the systems that surround it. That involves you gathering a lot of information. You have to gather the information. You send drones up, or at least you employ companies who can send drones up, take lots of photographs, stitch those photographs together, and make it look like a three-dimensional model. And once you've created that model, you have to play around with it in real time. You want to make sure that you can move it. So, in many instances, you're using technologies that you would typically see in things like video games because you want the thing to be as smooth as possible. You want to be able to, dive into it in a huge amount of detail. Those are actually complicated and are expensive. Um, but the benefits that you get from actually having them in place are actually, quite high because they're not just used in terms of representing the network. They can be used to do things like cell capacity on those towers. So I think the use cases for a lot of these things are pretty well understood now. We understand how to put them together, and we've got a lot of expertise and background in doing it.
So, where do you see the role of digital twins evolving in the next 3 to 5 years for telcos? Are there emerging capabilities or use cases that excite you more than others?
Yeah, there are a couple that are kind of like out there. I mean, where we are at the minute, there's a lot of focus on things like prediction. So prediction's really only useful if you can take action on the back of it. So if, for example, knowing that a network component will fail in the next hour isn't particularly useful. because there's not a lot you can do about it. You're kind of like Cassandra. You have all the you have all the trust, but you can't actually do anything in real term, in real life, about this. Same thing's true if knowing that it's going to fail in 6 months. There's not a lot you can do. But if you know with a high degree of accuracy that some component of the network is going to fail in the next 2 weeks, that is something you can do about. You can actually, integrate that with what your field service teams are doing. You can integrate it with your inventory. So that kind of like reduces cost and improves quality of service. So a lot of the leading edge solutions at the minute leverage prediction in that way. And we've had like one or two examples of this starting to move out of proof of concept and into real operations. So that's a fairly well understood kind of like issue. If I think about the things going forward that might be interesting, um, well, you can't really talk about digital twins and simulation without considering the impact of AI. AI is top of mind for lots of people at the minute. And AI has actually been used in the telco vertical for decades. If you're to pick a vertical out there that really understands AI, telco would be close to the top of that list. We've had it in the past. We just called it machine learning. We didn't call it AI at the time. And if I'm looking forward, so in your 3 to 5 years look ahead kind of stuff, we can see it being applied more in the radio access network and the RAN and in the core. A lot of people have talked about at some point in the future getting to things like zero touch networks, where the amount of human involvement starts decreasing a lot more. Digital twins are going to be useful they'll be key in understanding just how far you can take that and how tightly coupled those networks can be. The concern is if you get a very tightly coupled network, then you're going to get edge behavior that is detrimental, that is bad. You'll get some circumstances where the system is thinking it's making the right kind of decision, but it isn't. And in those circumstances, you don't want that to be happening in the real world in real time. So digital twins will help us think through how closely coupled those things need to be kind of going forward. So I think those two things, using prediction today, and then going forward using digital twins to actually think about how far we can take AI, those are the things that will actually drive a lot of the work going forward.
Wow. Well, Paul, thanks so much for sharing your insights with us today. Before we wrap up, where can folks go to learn more about UST and the work your team is doing?
Well, the most basic thing is just go to ust.com. There's a lot of information there in terms of who to reach out to, who to contact, and we can cover most of what you guys would want to see.
So, as we wrap, if there's one takeaway for our audience, it's this: digital twins give telcos the foresight instead of hindsight, improving performance, protecting customer experience, and delivering strong ROI while preparing networks for the future. And thank you to the audience for tuning in to this 10-minute take today, brought to you by UST and Technology Advice. And we'll see you here next time.